Hello. In this before class information, I'm going to follow on directly from what Steffi talked about in the lecture this week. That is model selection, or more specifically, variable selection. We have collected a data set, let's imagine, like the body fat data set, where we've got a response variable, percentage body fat in people, individuals, and a bunch of other measurements about those individuals. Now, it's very important to remember what Steffi talked about in terms of the difference between when we are seeking to explain versus when we are seeking to predict. Now, when we're seeking to explain, for example, percentage body fat in a person, we would immediately think about the things that cause someone to have low body fat or high body fat as being things like what the person ate, that is their diet, how much exercise they did, perhaps something about their genetics as well. That is what determines, that's what causes, that's what explains variation in how much body fat people have, whether they have a lot of body fat or a little body fat. If we were doing a study, therefore, of about explaining and understanding variation in body fat among people, we would want to measure those things. Now, this body fat data set that we've already worked with actually doesn't contain any of those variables, which immediately tells us that actually that data set is not about explaining variation in percentage body fat. It's about something else, because it contains other variables, the measurements of abdomen, circumference, thigh circumference, wrist, weight, BMI. None of those, like someone's weight, isn't the cause of them having high body fat, or someone's very low weight. That's not the cause of them having low body fat. It's the other factors like their diet, like how much they exercise, that are causing them both to have high weight and high body fat, or the reverse if that's the case. So with this particular data set, of the body fat data set, it should be immediately clear that we're not seeking to understand, we're not seeking to explain, we're not seeking to find out, we're not seeking a kind of causation or causative effects. All we're doing is trying to measure some things about people that are quite easy to measure. It's easy to measure someone's weight, and using those to predict something that's actually relatively difficult to measure, the percentage body fat. So that's what we're trying to do, that kind of prediction. Okay, when we're in that realm of predictive modelling, then we can do this kind of variable selection after we've collected the data. We call that a posteriori selection of variables. We're not trying to select the variables that are important. We're not trying to select those that are significant in any way. All we're trying to do is select a set of variables that gives us the best predictions, the best predictive power. And as Steffi said, that selection needs to take into account the fact that, well, if we put lots and lots of variables in, we can end up doing what's called overfitting. We create a model that's, in a way, it's too sensitive to the data. Whereas if we put too few variables in, then we create a model that actually doesn't contain the important factors that can predict body fat. So we need to have this balance, and that's where we use AIC, so we're going to have a go at doing that. It's important, before we move to that, it's important to realise and to understand that we've not done an experiment. The data set isn't the result of an experiment. If we'd done an experiment, we would have been choosing which variables to manipulate, would have been thinking about things in advance. We haven't actually done a great deal of thinking about causation in advance because we know we're not interested in that. We haven't done much a priori selection of variables to either manipulate or measure. So this is a posteriori, after the event model selection, rather than kind of before the event model selection. So that's very important to remember. One final thing, before we move to R, is that when you go to the literature, and read articles, you may quite often find people doing model selection and thinking that that gives them explanations and causation. And it may do, but the problem is we don't know when it has reliably done so or not. So it's actually a real kind of minefield. One can think that one's getting causation, getting explanation with this kind of a posteriori variable selection, but it's very difficult to know when we have done, because of things that Steffi talked about, like collinearity, for example. Good. So we're going to work with this body fat data, and we're going to repeat what Steffi did right at the end of her lecture and add a few special things to it. Well, not that special, but add a few interesting things to it. Good. So let's move to RStudio and have a go at just the preliminaries, getting the data in and getting the necessary libraries loaded. So I'm going to start RStudio. And close that down, close that down. Okay, I'm going to open up a new script now, a brand new script, and the first thing I'm going to do is make sure I have this line rm equals ls to clear R's brain. The second thing I'm going to do is label my analysis. So this is making a predictive model of body fat. I'll store that on the desktop, save it, and I'll just close R down, and then there it is, and I'll reopen it that way. Good. So the next thing we need to do is load some libraries, the useful libraries we need. We're going to use a function from dplyr, so we'll load that. We're going to use ggplot2. We're going to use function from mass. Which other ones are we going to use? Oops. Let's have a look. Yes, we're going to use a function from readr just to read the data in. Oops, hit the wrong key on the keyboard. Readr, good. And then we're going to use a new package called moomin. I have already installed this package. You probably need to install this package, in which case please do so. Be very careful about the capitalization. It's capital M, little u, capital M, capital I, little n with this package. Be careful of that. Good. Install that. Load the library, and before we take a break, the only other thing that we're going to do is read in the data. Now, the data is called body fat clean.txt. Here it is. bodyfatclean.txt. It's a txt, so it's very likely it's tab delimited. That's why I'm using delim there. Let's run that, see what happens. Could not find function read.delim. That's because I forgot to run any of these previous lines. And read_delim, the function read_delim is in the readr package. I'm going to do Control A and then just hit Control Enter, run the whole lot. And delim is missing. I guess we have to put that in explicitly, and it is a /d. Good. Let's just see if that is what we expected. R is telling us it's passed with column specification. There are all the columns, it's passed, and we've got 243 observations. Good, that's exactly what we wanted. Make sure that you've read in the data, and after the break we'll move on from there.